So I want to introduce Dennis Wallace, and I wore a tie tonight because he's a PhD, and I wanted to impress him. So,
and I didn't. So
yeah, I'm trying to catch up. So please welcome Dennis, Dr. Dennis Wallace. Thank you.
Thank you. Okay, a little bit about my background. I'm a doctor in physics from Notre Dame, and my philosophical tradition is Aristotelian and Thomistic, which is a little different probably than what most of you are used to. But hopefully looking at things from a different direction will be illuminating or at least inspire some questions and thought. I wanted to talk a little bit about where this is coming from. So I published an article entitled Mind to Randomness and Evolution in the Journal of Interdisciplinary Studies a couple of years ago. And I have a book, God, Science, and the Mind, The Irrationality of Naturalism, in which this talk is about half of a chapter, a little less than half of a chapter. And I have a YouTube channel where I discuss a lot of issues in 10 to 15-minute talks usually. And while it's not Christian apologetics, it's very consistent with my Christian faith, and it allows people who are not necessarily dedicated to faith to see the faith it doesn't contradict what we can know by reason. So I concentrate on what we can know by reason. It seems to me that the main problem that people have with evolution is the idea that it denies divine providence. Okay, a little history about evolution and the problem. The traditional proofs for the existence of God, starting with Aristotle and then the Muslim Avicenna, who was known as Avicenna in the Middle Ages, and Thomas Aquinas, all of those proof traditions were deductive. They started with things which people could agree upon, and then by strict logical deduction, they arrived at the existence of God. Of course, when you do this, you don't come up with a Christian God. You come up with a God who's the ruler of the universe, supreme being, self-sufficient, self-maintaining. Aristotle called him self-thinking thought. And Aquinas realized the limits of this as far as Christian faith goes, that logic and knowledge can bring us so far, but it can't bring us to faith. So there's no pretense in proving the existence of God that we're going to convince people to necessarily become Christian. That's another step after that. So all of this tradition, which had gone through Aquinas and continued in Spain and continental Europe, at least in the Catholic sections of Europe, for deductive proofs, died out in England. And in England, a new tradition of proof started, and it was an analogical tradition. William Paley wrote a book called Natural Theology, in which he rehearsed a proof which had been around for about 100 years or so, in which we look at the complexity of nature, and just as if we were looking at a pocket watch that we found on the moor, we would say this must be made by human beings. So when we look at nature, Paley argued we have to say that this is the work of God. And so that was basically the foundation stone of Anglican apologetics at the beginning of the 1800s. All of that was challenged as a result of evolution coming into being. Evolution coming into being wasn't just a shock to people of faith. It was also a philosophical shock, because people believed that there were fixed species in the world and that species were some sort of Platonic form that could never change. And the idea that species could transmutate, which was the word that was originally used, or evolve, was kind of an intellectual blow. Very stunning. Okay, so the name of Darwin is usually associated with evolution, but pride of authorship actually goes to a fellow by the name of Alfred Russel Wallace. Wallace was working in Indonesia, studying the species there. He was a naturalist. He had a passing acquaintance with Darwin. And while Darwin was sitting on his derriere working through his notes and 2 or 3 years away from publication, Alfred Russel Wallace sent a paper in to be published. One of Darwin's friends got it to review and said, "Hey, wait a second, you're going to get scooped, Charles." So they got Charles Darwin and Alfred Wallace to make a joint presentation in which they both presented evolution as their combined work. So really, Wallace is a co-founder of evolution. And that's important because we're going to see that Wallace and Darwin had very different takes on evolution. The theory they came up with depends on 3 points. First, that there are random variations. That is, the species, individuals in the species might be a little bit taller, a little bit shorter. They might have a slightly different color, or they might grow longer hair, or whatever. But each individual has random variations. And natural selection, survival of the fittest, selects out those variations which make the descendants of the creature that have them live longer. So if it's a cold climate and you're growing longer fur, then your descendants, if they inherit longer fur, are more likely to survive. And so that trait will get passed on if it is inheritable. Some traits are not inheritable. Lots of traits are not inheritable. So it has to be inheritable, and that goes back to the idea of genetics. So there has to be some sort of genetic basis which can be inherited for this so-called random variation. And because this process can explain the species that we observe today, that was taken as a counter-argument to Paley's argument that the diversity and beauty of creation implies the existence of a designing God. But evolution itself does not reject God. Frankly, evolution was hijacked by atheists. The most recent example is Dawkins. Dawkins has written a number of books, and frankly, if you know what your science and your philosophy, Dawkins' books are a lot of baloney. For example, one of his arguments is to show that evolution will go faster than random processes, and the way he makes it go faster is by programming a target into his computer program to simulate randomness. And so with a predefined target, yes, you get the answer out faster. But that is not a counterexample for design. In fact, he put the answer he wanted in by design, and he got it out. So Darwin was not an atheist. He believed in design laws. Darwin had a troubled life. His daughter died at an early age. That really upset him. There was a crisis of faith for him. And after that, he stopped going to church. And outside while his wife and children went in. So he believed that the laws of nature were designed, but the details were left to chance. God didn't care what happened after he designed the laws. He walked off. This is a kind of a deist stance, the clockwinder God. And there's a long tradition of that in English thought as well. So he was troubled not by thinking that there was no design in nature, because he did believe in designed laws. He just thought he was concerned about the problem of evil. The objections he brings to God are, why would God make creatures that burrow into living beetles and feed off of them as they're growing up? Surely God would be more merciful than that sort of argument. But not an argument against design per se. Wallace, on the other hand, was a very spiritual person. He believed that evolution showed mind action and guidance, and he was, to the end of his days in 1913 or so, he was very much a proponent of an intentional God existing and operating through evolution. So the Christian responses we all know. Creationism, basically taking Genesis very literally, and maybe with some interpretation about how long days were or something of that sort, but basically a very literal interpretation of Genesis. And this is an interesting sidelight to this, is that during the 19th century, evangelical Christians were not very liberal-minded about Genesis. They were willing to accept a whole range of interpretations of Genesis, which were more figurative and less literal. But then, as a result of some essays called Fundamentals that were published in the early part of the 1900s, 1910 to 1913, they became much more set and much more liberal in their interpretation of Genesis. Intelligent design, which I put quotes around because there are many ways of having intelligent design other than what the intelligent design people propose, is a theory in which the broad outlines of evolution as a historical process are kind of accepted and that species have evolved. But intelligent design people believe that there are structures in nature which are irreducibly complex. That is to say that there's no path that we could think of from an earlier species to something having this structure which makes sense to us. And so that God therefore must have intervened to create this new structure. And so the flagellum, which has a bearing and a motor that drives it around in circles, they can't see how that could have evolved stepwise. That it had to be, since it's irreducibly complex, you either have all of it which works or none of it, but some intermediate stage won't work. The problem there is that we are beings of finite intellect. Aquinas makes the point that we have fallen intellects as a result of fall, and therefore our intellects are not able to see everything that's possible. And so the counter-argument to irreducibly complex structures is, well, just because we can't think of an intermediate stage doesn't mean that one doesn't exist. You're just asking us to make a leap of faith. So why have intelligent design? Well, we want intelligent design to show that God is active in the universe, that God is active in the process of evolution. The final response is theistic evolution, which says basically evolution is just the way science describes, but that's how God has chosen to create, and it's not up to us to dictate to God how he wants to do his creation. So if science reveals that he's created via this evolutionary process, then that's what we've learned from our study of science. I have 4 points which I'm going to make in the talk. The first point is a very simple one. Having a mechanism doesn't rule out having an end. When you talk to people who are against teleology, teleology is the idea that natural processes are directed toward goals. Okay? When people object to teleology, the counter-argument is, well, we know a mechanism which will provide us with that answer. And so we don't need to have an intelligent design or an intelligence driving the process. It doesn't need to be goal-directed. It's just the result of a mechanism. But ends require means. Whenever we have an end, and it's not present before us, then we have to invent means, mechanisms, to accomplish those. And so if God desired to create the physical structure of human beings, for example, he might very well come up with a mechanism, which would be exactly what evolution finds, which is compatible with science. But that the existence of a mechanism isn't a counter-argument to the existence of ends, and in fact, ends require means, and means generally arrive at some end. And so they're just basically two ways of looking at the same process. They're not contradictory. They're not counter-arguments for each other. The second point is that evolution is guided by intentional laws of nature. As a physicist, of course, I spent a lot of time thinking about laws of nature because physicists use laws of nature. And I read a great deal of philosophy of science, and I couldn't find anybody who actually talked about laws of nature. If you read The Grand Design by Mlodinow and Hawking, which was one of the hot books of the last few years, you will find the claim that people who believe in religion believe in gods who just make up random decisions, are inconsistent, subjective, fatuous in their ideas, and that we needed to wait until the Greeks suddenly appeared on the scene to have the idea of laws of nature. Well, that's just bad history, because the laws of nature appear in Jeremiah 31. In Jeremiah 31 it says, "This is what the Lord says. He who appoints the sun to shine by day, who decrees the moon and stars to shine by night, who stirs up the sea so that its waves roar, the Lord Almighty is his name. Only if these decrees vanish from my sight, declares the Lord, will Israel ever cease being a nation before me." So what he's doing in this passage is he's taking the recognition that the laws of nature are constant and immutable, and Jeremiah is using this to argue that so God will also be constant to Israel. But if it wasn't a culturally accepted proposition that the laws of nature were constant and invariable and an expression of the will of God, then the idea of using them as a paradigm for how constant God is going to be to Israel wouldn't make any sense. So Jeremiah reflects a tradition in which the laws of nature come from God and are constant. Back to modern philosophers. Modern philosophers ignore the laws of nature. That's what I found out when I researched this. Instead, they concentrate on what we might call the laws of physics. They call them the laws of nature, but they're really the laws of physics. And the difference is this. The laws of nature exist in nature. The laws of physics exist in the mind. The laws of physics are things that physicists make up to approximate what we find in nature. They're equations which work very well. Newton's laws worked very well. They weren't perfect. They got improved by Einstein. They got improved again by quantum mechanics. But the laws that Newton discovered existed in nature to some approximation. The laws of nature explain natural events. The laws of physics explain scientific thought. It's because of the laws of nature that the Big Bang and evolution occur. It's because of the laws of physics that some theory that we're thinking about makes sense. So the laws of physics are mental constructs, but they're not pure constructs, they're not fictions. And they're based on laws which are actually operative in nature. The laws of nature that are created by God. I have an argument showing that, but I'm not getting it here. And the laws of physics are created by human beings. So the laws of nature are real. Physics isn't fiction. Physics is a description of reality. It's not some work like Charles Dickens' Great Expectations. The laws are discovered in nature. They're not invented. We invent approximations to them, but if the approximations didn't reflect what we find in nature, they would be worthless. Finally, if you're arguing with somebody who says, no, they don't exist, then non-existent laws can explain nothing. So if you're going to explain the Big Bang by some physical theory, then you have to assume that there are laws of nature operative at the time of the Big Bang in order for the Big Bang to occur. And if those laws didn't exist, there wouldn't be any explanation. Because the fact that we later, 13 billion years later, have come up with some cosmological theory doesn't explain the events that happened 13.75 billion years ago at the Big Bang. So only if the laws are real can they be explanations. So what's a law of nature? Well, they're immaterial, which is shocking, because materialists use physics as their paradigm for the way in which we should be thinking about the world. But the laws of nature are not made out of atoms, they're not made out of quarks or electrons or protons or positrons or any of the particles that physicists normally talk about. And in fact, the very idea of asking what are the laws of nature made of shows that you don't understand what the laws of nature are. It's called a category error. So the laws of nature are specifically immaterial, which means that part of the foundations of physics is the assumption of immaterial realities, the laws. They're a source of guidance. They guide processes. We start out with certain initial conditions. If we know what the laws of nature are, we can oftentimes tell what the final conditions are going to be. And so Jeremiah was right. They're intentional. I've got a longer argument and more detail that shows they're intentional. So this is a scary slide because I have put an equation in it. But I did this in order to show that physics actually does have two kinds of entities. These things, which I've got in purple and yellow on the outside, are material descriptors. They're called state functions or states. And what they do is they describe every material property of a system. Its mass, what kind of particles it's made out of, how far apart they are, what their wave functions are, everything that we can write down about instantaneously what the world looks like that's in that initial state, or at least a part of the world that we're studying. Then, sometime later, we'll have a final state. But what connects the two is the laws of nature. And so, just as my intention to go to the store while I'm sitting in my office later brings me to the store, so the laws of nature are the intentional structures which bring the initial physical state, which is material, to the final physical state, which is material again, but the connection between them is immaterial. The next point. The big thing that people like Dawkins and others who attack the idea of design in nature use, their argument is that no, we don't need design because random processes, and then they put mindless in parentheses, or sometimes they put mindless right in front of random, mindlessly random processes, can bring about all of the structures that we see around us, in particular our biology. Well, randomness is not something which exists in reality. Randomness is subjective, and I'll show you how we can make a very simple argument. So here's our urn that you've heard about any number of times when you're studying or hearing about probability. And you reach into the urn, and you've picked out 99 balls, and they're all white. So now I ask you, what is the probability that the 100th ball is going to be white? And there's a formula to calculate this. It's due to Laplace. And Laplace's formula tells us that the probability of the next ball being white is 100 over 101, which is better than 99%. However, I happen to have put the balls in the jar. And I know that I put 99 white balls in the jar and 1 red ball. So for me, it's 100% certain that the next ball you pick will be red. But for you, it's 99% certain that the next ball you pick will be white. What's the difference between us? Knowledge. You lack the knowledge that I have. And so randomness is a measure of ignorance. Another example. We throw dice. This is supposed to be a random process. It's random because nobody can predict it. But if we had microscopic observations of exactly how the corner of the dice hit the felt on the table and what its angular momentum was and exactly what the mass and construction of the dice was and the coefficient of friction and everything else, we could figure out what side was going to come up. It's a deterministic process. It's only random because we humans are ignorant of the outcome. We humans are unable to predict what's going to happen. And so randomness is a measure of ignorance. It is not something intrinsic to nature. So the final point is that fitness implies pre-existing standards. Remember that evolution depends on the survival of the fittest, natural selection. So what does fitness mean? Well, if fitness means only that what is fit is going to be more survivable, then we don't have a scientific principle at all. All we have is a circular statement. We have a
tautology?
Yeah, tautology, exactly. We have a tautology. And so for survival of the fittest to mean anything, there has to be some standard of fitness that we could say before we look at the outcome. If this animal, this plant, has more of this, is closer to this norm, then it's going to survive on the average, and if it's not going to survive. So we need some sort of objective standard. So we need to have a prior objective standard for this theory to be an actual scientific theory as opposed to a tautology. So if fitness is objective and it's prior, where does it exist? It's prior to the animals that are supposedly fit or not. And the answer is it's implicit in the laws of nature. The laws of nature tell us that if you're exposed to cold conditions, sub-zero conditions, and you don't have enough insulation, you're going to freeze. Okay? That's an objective situation which is implicit in the laws of nature. And so the idea of fitness is the idea of something implicit in the laws of nature. So evolution is guided by intentional laws of nature. The intentionality at the top, in terms of the criterion of fitness, that there is some goal or standard toward which more fit individuals are striving. And it's intentional at the bottom because the laws of physics are intentional and they 100% control the mutation that occurred. You've all heard about quantum mechanics being random. People don't read the textbooks. What quantum mechanics says is that unobserved physical processes are completely deterministic. That is to say, if you start with one set of initial conditions, you don't stick your finger in by observing it, you're definitely going to get one and only one final condition. It's only when we make observations and we stick our finger in some unknown way that probability and randomness occur in quantum mechanics. So for the 13 point, let's say, 1 billion years over which there were no intelligent observers, evolution is entirely, if we believe physics, evolution is entirely deterministic. It's not random at all. It's all pre-coded in the Big Bang. That's what physics tells us. This is not some theological statement I'm making. This is textbook physics. So evolution is intentional top to bottom. And so now our doubters come forward and they say, but teleology, the idea that processes are goal-directed, it's not empirically testable, it's just some subjective feeling you have. Well, Aristotle took care of that for us. Aristotle made 3 falsifiable claims about what intentional natural processes should involve. The first is that there should be means-ends relationships in nature. That nature should have means and ends, and those relationships ought to be clear. The second is that there are target forms. That nature tends toward definite deterministic outcomes, determinate outcomes, let's say. And finally, that there are means prepared in advance of need. That we don't wait until we get to laying the brick down and say, oh, gee, I forgot to make some mortar. No, you make the mortar first, then you go over and you lay the brick. So these are the 3 tests that Aristotle put down, and they're all observable things that we can question evolutionary biologists and see if they exist in evolution. So do means-ends relations exist in nature? Of course they do. What, do spiders just build webs randomly and then happen to catch flies in them and then happen to eat them? No. Spiders build webs as means of catching flies. Do lions chase prey in order to just have fun and then accidentally catch them and munch on them? No, they chase prey in order to eat them. So all of these natural processes that we observe in everyday biology are ordered to ends. Does evolution have target forms? And here's where people don't know very much about evolution, and so they don't understand that it does. The first is that there's a new theory that's not too new now. It's about 20 some odd years old, called punctuated evolution. Paleontologists were studying the Paleozoic trilobites, and they found that from the first appearance of these trilobites in the geologic record, through their disappearance, the forms never changed. Darwin had talked about evolution as a gradual process that was sort of interminably drifting. That's not the way evolution actually works. Biologists now know that very quickly after a catastrophe, like say an asteroid hits the Earth, that within a very short, geologically short period of time, the whole ecosystem evolves, and as long as the conditions stay the same, that ecosystem stays the same. There might be little minor fluctuations, but this same trilobite existed unchanged. And so the new theory of evolution involves punctuated equilibrium. That when a disaster happens, quickly species evolve to accommodate to the new conditions. Then once they're evolved, we reach a state of equilibrium, and they don't change after that until the next disaster. Okay, so that's the first point. The second point is there's something called convergent evolution. So here is Euphorbia of the deserts of Africa and Southeastern Asia, and the Cactaceae of the New World desert. So in the New World, in North and South America, we have the green cactus, and over in Africa and Asia, they have this other cactus. Well, these cacti are completely unrelated genetically. They're in different genuses. They have different backgrounds. But this form is pre-programmed into the criteria of fitness so that eventually that species or that genus of plant evolved this form. And in the Americas, this other entirely different plant line evolved a virtually identical form. So these forms seem to be pre-programmed in the criteria of fitness. So we could say, actually, that they're targets. And here's the example. Here's another example. 375 million years ago, the placental animals and the marsupial animals split. So the marsupial animals are the ones that we find in Australia, and they're like, kangaroos and Tasmanian wolves and that sort of thing. Okay. Then the marsupial animals, which haven't had a common ancestor since 375 million years ago, it evolved into a wolf, and the Tasmanian animals developed a wolf. So now you see that the forms of the skulls are virtually identical. Any common ancestor that these had was more than 375 million years ago, and there was some little mouse-like creature. Okay. Despite that, these two independent lines have developed into very similar, almost identical structures. So now we ask the next question. Does evolution prepare means in advance of need? And this used to be a question that people would say, no, we couldn't have. Well, it does. So this fish is called Tiktaalik rosier, and it was discovered up in Ellesmere Island in, I think, around 1992. No, more recently, 2003. Okay, so Tiktaalik is the fish with wrists. Here's the wrist. That looks very much like a modern wrist structure. Now, the problem is fish have absolutely no need for wrists. None. They have found the living cousin of Tiktaalik in South America, and it has exactly the genes required to produce wrists. They're called toolkit genes. So the toolkit out of which wrists evolved, which are the toolkits necessary for our hands and feet and for any kind of animal that has fingers and so on, evolved before there was any pressure to have wrists, fingers, hands, and so on. So this toolkit is a pre-existing toolkit, and programmed into it is the ability to develop wrists, and how those abilities are expressed, controlled by what's called homeobox genes. And homeobox genes are basically little knobs that let the toolkit genes express themselves in slightly different ways, like longer fingers or shorter bones and so on. So here, this means of evolving wrists existed before there was any need whatsoever for wrists. So here are my points. Having a mechanism doesn't rule out having an end. Evolution is guided by intentional laws of nature. The laws of nature are actually intentional. They're very like human intentions. Just as my intention to go to the store leads me to the store, so the laws of nature lead initial states to final states. Randomness is not an objective property of reality. It's a reflection of human ignorance. And finally, fitness implies pre-existing standards and targets. That's my talk. Thank you very much.